received many grants and fellowships. Those are TARE Fellow, then SERB ICER Pune Fellowship, also Indo-USA Postdoctoral Raman Fellow he is. He had many research and postdoctoral, he has much or rather a wide experience as in research and postdoctoral, like doctoral thing. He is research supervisor, RTM, Nagpur University. He is Raman Fellow. He is postdoctoral fellow advisor in TIFR Mumbai, postdoctoral fellow Wilfred Laurier University, Waterloo, Canada. He is research fellow in Catholic University of Daegu, South Korea. His educational qualifications are, the highest qualification is he is PhD in physics. He has qualified SET also. He has done his MSc physics, that is graduation and post-graduation from Jalgaon. He is invited for valuable talks by many esteemed universities and institutes, in which I'll list a few. It's Department of Physics, Shivaji University, Kolhapur. It's SPPU, that is our Pune University. It's Raisoni College of Engineering, Jalgaon. It's university level SETNet workshop he has conducted in Solapur. In Nashik also, he had given many talks in Wagh Institute of Engineering and Research. Also in Amravati, in Surat, in Pune, again, that is in COEP Pune, he has delivered his valuable talks. In the organizations or conferences and workshops he has attended, they are he has organized, first of all, the National Conference on Advances in Science and Forensics, Physical Education and Sports, that is in 2025 in Institute of Science, Nagpur. He has organized a workshop on research promotion at Institute of Science, Nagpur in 2024. He has organized a workshop on multi-scale modeling and simulation, Department of Physics in COEP in 2018, again in 2012, and he was organizing member of Avishkar 2012 in COEP Pune. His professional training and participation and other activities are, he is providing career counseling and placement cell. He is in charge of that. He is Science Club advisor and founder member in College of Engineering, Pune. He had organized 1 week faculty induction program in NPUI at COEP Pune, 2 week NITT TR induction phase 1 program in Goa. Also, he had organized many different workshops in many different institutes. So if I go on listing all these things,
no, I think,
I
madam,
hope,
thank you.
10 or 15 minutes will be required more. So with this short introduction of our today's speaker, Dr. Patil sir, I invite Dr. Patil sir to deliver his valuable talk and guide our NGPE students and to us also. Thank you, sir. Welcome all.
Okay. Thank you for long introduction, madam. Thank you. So first of all, thank you to IAPT for having me for this particular session. Without wasting further time, I think I can start with my session. So yesterday, I think I was thinking to take some mathematical physics problems, but I think yesterday some of the part is covered already. So I have slightly modified my session to like applied like the mathematical physics applied in different parts of physics, like in mechanics, in electrostatics, magnetostatics, and so on. So I will take some of the problems which were uh, which were asked in previous NGPE examination, just for the students to get the flavor of NGPE examination. And I will try to also introduce some of the concepts which are relevant and useful for the students to solve these kind of problems. So I'll start. I think I just want to, before I start, I just want to make sure that everyone is able to hear me and see the
Yes,
screen.
yes, sir. Yeah. Clear,
Okay.
very clear, very clear.
All right.
Go ahead.
And I expect students, please ask questions, and please also try to be interactive. I will try to get some questions also, as well as in between, I will ask some questions. So if you have inputs, and I also highly recommend to continue solving parallelly with me, so that you will better understand it, because I'm not going to solve it by hand. I'm using slides, but I will make sure that you will get the feel of problem solving. If you solve it with me, that will be great. Then you will realize the problems raised while solving difficulties and different concepts. We'll try to discuss them. So my original plan was to introduce the differentiating fields and integrating fields in physics, out of which I have skipped some of the parts, and then directly go to the problems. So if you have any like in between, if you have any doubts, you can always ask related to mathematical physics or the problem itself. Okay. So we are going to discuss briefly, very briefly, the gradient, the concept of gradient. In fact, we'll start with dot product and cross product also, just to get into the topic. And then I will also introduce you gradient and divergence and curl, basically the del operator. Followed by, I also had a plan to introduce you to the line integrals, surface integrals, and the volume integrals. But I think I'll take some of the problems if time permits based on this, instead of going into the theory. So let me share. Okay. And I think if the bandwidth is a problem, then I think I will stop my video, but I will share the screen uh, so that there is no problem in network. So the dot product, we have been hearing about dot product and cross product. So uh, the reason we have different products because of the involvement of the direction in the vectors. So otherwise, we just know the scalar product. I mean the A into B type of product, which is for scalars. But here we have additional information about the quantity, that is the direction of the quantity. For example, of the force and displacement. So for that, we have to do two different types of products. One of them is the dot product, which is also known as scalar product. It measures actually the parallelness of the two vectors. Okay, how parallel they are, how similar they are in the sense of direction. So if you look at the equation here for the dot product, that the magnitude of the vectors times the cosine of the theta between them. So the cosine of theta, you know that cosine of theta is 1 for when theta is equal to 0. That means when the two vectors are exactly parallel to each other, then this dot product gives you the maximum value. Okay. Whereas if the theta is 0, I mean theta is 90, then cos theta becomes 0. That means whenever the two vectors are perpendicular, then this dot product vanishes. That means it gives you the 0 value. Okay, so you can say that this dot product is a measure of parallelness of the between parallelness of the pair of vectors. Okay, so if it is parallel, you get the maximum magnitude. If it is perpendicular, you get the 0. And when the two vectors are perpendicular, they are called as orthogonal vectors. Okay, remember this. Maybe in some problems it will be simply mentioned that uh, let's have a pair of orthogonal vectors. Then you should quickly understand that that means f dot d or a dot b. If a and b are vectors, then a dot b will be 0. Okay, and if it is mentioned that they are parallel, that means you can take theta equal to 0, and simply the f dot d is f times d. Okay, in physics we use this dot product often, like in here I give you the example of work, which is a dot product of force and the displacement. Similarly, power, the dot product of force and the velocity. On the other hand, you have the cross product. Okay, the cross product basically results in, here the direction is not mentioned unfortunately, but it results in on a vector quantity. Okay, so here it is called, it is a dot product was called scalar product just because the outcome is scalar, whereas in a cross product the outcome comes out to be a vector quantity, and therefore it is also known as vector product. Okay, just like here the scalar product, the cross product is also known as the vector product. So what we get basically from the cross product is a vector which is perpendicular to the actual or both the vectors basically involved in the cross product. So in terms of physics example, the torque, which is r cross f, r is the distance which is mentioned in here. Okay, where distance where basically the force is acting. Okay, so r cross f gives you sine theta. Just remember here we get the cos theta in dot product and sine theta in cross product, and there will be a directional vector, basically the unit vector which is perpendicular to r and f both. All right, so just exactly the opposite of dot product, the cross product measures the perpendicularity of the vectors between the pair of vectors, how whether they are perpendicular or not. If they are perpendicular, then this cross product results in a maximum value, that is sine theta, sine of 90 becomes 1, and hence you get the maximum value of the product. Whereas if it is again, if they are parallel, then it becomes 0 because sine of 0 gives you 0. Right. So the examples are torque, which is mentioned here, as well as the magnetic force, okay, acting on a charged particle. So V cross B, basically Lorentz force, if you remember, where you will have also the electrostatic force if there is electric field involved. We will see maybe a couple of problems based on this. So I hope the dot product and cross product, the concepts are clear. So if there are questions, please, you can interrupt me in between, no problem. Otherwise, we will move
Sir,
for the, yes, ma'am.
no doubt, but can you go for full screen? If
Okay, it's
possible,
not full
yeah,
screen.
because
Sorry, it was full screen, but
no.
then I think it was okay.
Oh,
Now,
that's great. Thank you.
okay, thank you, ma'am.
Yes, yes, perfect.
Okay, all right. So we'll go for the next part. So the del operator, many students face this operator if you are doing physics, then you cannot avoid this operator. Okay, so the del operator simply is a vector operator. Okay, you can have, so it is a vector differentiating operator over the fields. Okay, so you can have a scalar field, you can have a vector field. And this operator basically is a linear operator, so it basically operates linearly. That means if there are a plus b as an operand, then this will operate on a as well as on b. Okay, so what this basically is a partial derivative in x direction, partial derivative in y direction, partial derivative in z direction. There is a mistake in here that it should be dabba by dabba z and k cap. Okay, I cap is a unit vector. I think you all familiar with. In x direction, j cap in y direction, and the k cap, there should have been k cap, which is in z direction. So unit vector basically are just used to mention, are just used to provide the information about the direction. Okay, it has a magnitude of 1 simply. Now, with this del operator, we can operate this operator on scalar field. Okay, then we get the gradient of that particular field. Let's say F is a field here. Let's say you can say that there are two regions. One is positively charged with +1 charge, and the another is also positively charged with the +2 charge. Now there is a potential difference. Okay, so and therefore there is a gradient. Okay, the gradient is basically a special rate of change. Okay, you can understand this way, like the concentration gradient, we know, like whenever you spray, let's say, perfume molecules in a corner of a room, then they spread because of the concentration gradient. That is basically simply the difference in the concentration at different locations. Okay, so the gradient is always commonly referred with respect to the position, but not necessarily. If you go into quantum mechanics and all in higher classes, you will see that gradient is also defined with respect to momentum or the k vector and so on. All right, so the basic idea here is, if you want to measure the spatial difference with respect to space or for any quantity which is scalar, then you can use this gradient. Okay, the good thing, or the special thing about the gradient is, when the gradient, uh, which is a vector derivative, basically operates on a scalar, results in a vector again. Okay, so results in a vector again. It should have been x, y, and z here, but and k cap here. Okay, so it simply operates on f and giving you the partial derivatives as well as the directions, respective directions in x, y, z uh, directions, basically. So you can also understand, like when you heat a rod at one end, and you measure the temperature of the rod over the period of time also, or just with respect to space, you will see that the temperature is different at different locations. So you can say that at different locations the temperature is different, therefore there is a gradient. And if the temperature is uniform all over the place, all over the rod, then you can say that the gradient of temperature is zero, because temperature, even though the temperature might have increased, but it is uniform, therefore you can call it as the zero gradient. Okay, so in that case the thermal field has no gradient in that case. Okay, the F will be a thermal field in that case. If you take this example of charges, then F will be your shall I expect answers? All right, so I think
Yes,
we'll
yes,
go
yes.
ahead. Okay,
Thank
if you can also write in comments, that is also fine. So F will be, if you expect here, like if there is a potential difference, you will expect the electric field. But since electric field is not scalar, so we will have to look for the another operation of del on vector quantities. Okay, so one of them is, just like I mentioned, there are two types of products: dot product and cross product. So similar here, it is a del operating on the vectors. Since when it is operating on scalar, it is simply giving you gradient. Okay, there are no two types of gradients, it's only simple, because F is a scalar. Whereas when the F becomes vector, then you will have two types of operation of del. One of them is dot uh, product, you can say, dot product of del and F. The difference here is del is an operator and not simply a vector. So we will call it as a divergence. Okay, so the del dot F gives you the divergence of F. Okay, gives you the outcome as in divergence of F, and the surprisingly you will get a scalar quantity. Okay, the dot product, as we already know, dot product results in a scalar quantity. So here also the dot product between del and F results in a scalar quantity. Okay, and what divergence means, basically, if you have simply a positive charge, then and you draw the field lines, they will be diverging away from, they will be going away from the plus charge, and therefore we call it as diverging field. Okay, whereas if you go for the curl, okay, which is a cross product between del and F, again del is an operator here. So the cross product gives you how basically it is swirling, okay, or the swirling of the electric field or any field basically, okay, just like in a whirlpool you must have seen. So there you see the water is swirling around a particular point, and you can say that there is a curl of water, okay, or curl of motion basically. So how to calculate the curl of a function, curl of a vector, is basically simply just like this, but you will have a slight change here because the curl is again the del operator is as it is, but f will be a vector. So f will have f1 I cap, f2 j cap, and f3 k cap. Now when this del, as I mentioned in previous slide, that the vector product or the cross product results in a direction, results in a vector quantity having a direction perpendicular to both of these vectors. So for example, if del, you take this particular part dabba by dabba x only, so it is a vector in x direction. And if you take a cross product with f with respect to the x component of f, then what will happen? You will have I cross I. Okay, that means the derivative is also in x direction or with respect to x direction, sorry, in x direction, and the vector also is in x direction, the component of x component of the vector. So as we discussed that the cross product is a measure of perpendicularity. If the perpendicularity is more, or you can say if it is perfectly perpendicular, you get the maximum value of the cross product. And if they are parallel, then you get the minimum value of the cross product, that is 0. So f1 and dabba by dabba x I cap and f1 I cap are parallel, therefore you get the 0. Okay, so therefore I cross I will be 0. Similarly, j cross j will be 0, k cross k will be also 0. So rest of the things you will get is this determinant basically. Okay, so you will have a I cap times dabba f2 of dabba x, dabba f2 with respect to dabba x similarly, and minus dabba f1 by dabba y, and so on. I think you know the determinant, how to solve it. We will see a couple of examples, then we will be able to get the idea about the cross product, how to get this determinant solved. All right, so we have these three operations of del. One is on scalar, that gives us gradient. One is on two are on vectors. One way is dot product, another is cross product. When you take dot product, you get the divergence, that is how it is spreading, how it is going away from the center point, you can say. And the curl is how it is revolving around a particular point, or swirling, or you can say a whirlpool as an example, and so on. Okay, so just with this information, now we will start to solve the problems. And there also, whenever the new concept or new identity or the formula is used, we will discuss that. So the one problem I looked at when I looked at the old question papers, but it is not necessary that you will always be asked and I have not seen a repeated question in NGP, so don't only revise the old question papers. I recommend you to solve more and more problems. So let's say we have a problem here that the electric field, which is a function of r in a certain region of space, varies proportional to the position vector r, and is given by, so simply if some vector or some function is varying with respect to r only, that means you can say E of r is directly proportional to r, and the proportionality constant is given here as an alpha. So alpha is a constant. Many times you will be only given a statement and not the formula, so you are supposed to express this statement in the mathematical form, just like expressed here. E of r is a constant times r. Now if the absolute permittivity of the medium is epsilon, then we are asked to find the volume charge density. Okay, we are asked to find the volume charge density. So can we get some idea from the audience, like how do
So
we
use
start?
Gauss theorem.
Sorry.
Gauss theorem.
All right, use Gauss theorem. You mean Gauss divergence
Divergence.
theorem? Gauss
Yes,
divergence
sir.
theorem, right? So let's look at basically what we have. So we have the E of R, as we mentioned, and R we can express in terms of X, Y, Z, and then use, as the student rightly pointed out, the divergence theorem. And we know that from the Maxwell's equation that del dot E, the divergence of electric field, gives you rho times rho by the epsilon, where epsilon is the permittivity. So if we take the divergence of this particular vector, that is electric field, then we will be able to get the volume charge density. Which is volume charge density in this formula?
Rho.
Do we have volume charge density in this formula?
Yes, rho.
Yes, rho. Already the symbol was given. So rho. Okay, so we are supposed to find out rho. Okay, and we have E. So if you simply take the divergence, you will get the expression for divergence of E, and then you will multiply it by epsilon, and you will get the correct expression. Okay, for rho. So it is a very simple problem. Just to give you get us started. Right. So simple, 3 alpha times epsilon. Right. So it was a multiple choice question. I think it was in a part 1. So if you have seen the NGPE question papers, there are, I think, there are objective questions in first part. Then there are brief, small questions, you can call them. Then there are some large questions like and descriptive, and maybe like answers are expected in maybe 10 lines or 10 statements and so on. So this was simply objective type of question. Okay, I did not want you to get the options, so that we can discuss on how to solve instead of which options are correct and wrong. Let's get slightly complicated now. Next problem. A point particle of mass m and charge q moves with the initial velocity v0 I cap along the x-axis. It is not necessary to mention that it is along x-axis. Whenever there is I cap, you are supposed to understand that it is along the x-axis. The particle with this velocity enters in a magnetic field B. Okay, like in here, it is not mentioned that B is in z direction, but since it is k cap, you can interpret it as in a z direction, and B0 is the constant. Okay. Now determine. This is a descriptive type of question. So determine the magnetic flux enclosed by the orbit of a particle. Okay. Second part is the angular momentum of the orbital motion and corresponding magnetic dipole moment, as well as the ratio of mu upon L. That is, L is angular momentum. All right. So already the question itself tells you that it is expected that there will be angular motion, right? Orbital motion. Also, you can also say if the magnitudes match, you can get the circular motion. Okay. So it gives you an hint here that what formula is to be used. From the question itself, you can get some idea like which formula will be used here. What governs the motion? What gives you the motion? What gives you the motion? Like any object, how can you set it in a motion?
By applying force.
By applying force, that means we are getting into force here. So we have to think about a force acting on this particular particle. So what force is acting here?
Magnetic.
Magnetic force. Okay, so what is the formula for the magnetic force? We have already seen in maybe in a second slide already the equation for force. Magnetic
Q V
force,
bar cross V bar.
Q times V cross B bar, where Q is the charge on the particle, okay, and V cross B. So here V is a vector and B is also vector. But since we have V0 or the V, the initial velocity in I direction, that is X direction, and B, the magnetic field is in K direction. So they are perpendicular. We know these IJK unit vectors are perpendicular or are orthogonal vectors. So that means V and B are perpendicular to each other. Now we are having here cross product between V and B, and since V and B are perpendicular, what are we supposed to get? If V and B are perpendicular, then V cross B should be, V cross B will be maximum or minimum?
Maximum.
Maximum.
Maximum, because V cross B is VB sine theta, and theta is 90 degrees here, sine theta sine 91. So you will get simply Q times V times B. Okay, that is very simplified because your initial velocity is only in one direction as well as the magnetic field is acting in one direction. Okay, so it was already simplified for you. So since V is perpendicular to B, the force is applied always perpendicular to the velocity, and you will get a uniform circular motion in XY plane. Why XY plane? Why XY plane?
Because force is also perpendicular to V and B both.
Right. So in initial velocity, it was in X direction and B is in Z direction. Then you will have a resultant in Y direction. Okay. And since as long as V0 is not zero, you will have some motion in X direction, uh, and then the resultant of this will give you in motion in Y direction. Therefore, the motion will be confined to XY plane. There will be no motion in Z direction. Okay, so it will be a circular motion of the particles, of the charged particle in XY plane. Now that means you have a circular motion, then you can simply apply or balance the forces acting on that particle. Because of this Q is 0, B 0 is basically coming from your Lorentz force, magnetic force. Now it will be compensated by your mv0 square upon r. Which force it is? It is due to the motion, due to the circular motion. Is this equation correct? We are balancing two forces, but we only knew that there is one force, that is magnetic force. How do we get this particular force? This particular force mv square upon r is coming
Is
because
the
of a
centripetal force.
circular motion. Okay, all right. Now when we have this r, from this we will get the we will get the equation for the radius of that circle, right? So we can, because we will know v0, it will be initial velocity, we will know the strength of the magnetic field b0, m and q are constant, so we can calculate the radius of the circle in which this particle is moving. All right, so we'll get the radius. Now we want magnetic flux enclosed. Okay, now magnetic flux enclosed in this particular circle or due to this circular motion. Okay, so how do we get it? Magnetic flux. How do we define a
I,
magnetic flux?
sir, I think magnetic field per unit area.
Magnetic field per unit area.
So B dot A, right?
No, P dot A, that should be multiplied by A instead of divided by A. Okay, so B0 upon area. Area of what?
Of the like area enclosed by the loop.
By the loop. That means by the of the circle. Okay, so the area of the circle, pi r square, and since our B is only in one direction and it has a magnitude of B0, simply B0 times A. Okay, that will be your magnetic flux. So you got the expression for magnetic flux, but now you can express it in terms of, most of the times where the final result in physics will be a quantity which can be measured or which can be controlled. Okay, like we started with this R. Uh, the R can be measured. Okay, but still it is in between. So what we do here is we substitute A in terms of pi r square. R will be an outcome, so pi r square, but again R we will substitute in terms of this mv0 upon qb0. Then what we have is simply phi, okay, in terms of the quantities which we will know beforehand. Because these are externally controlled parameters which we can control. R will be intermediate variable, okay, which we will be able to measure. But why to measure if we can define phi by simply using V0 and B0? Rest are constants. So if the charge particle is electron, then you can use the mass of electron. Charge on electron, pi is a constant. So V0 will be controlled because you can control how fast the charge particle can go by applying appropriate electric field. Whereas magnetic field is also external, so you can control this. So the magnetic flux, if you want in a particular experiment, then you should be able to choose appropriate value of initial velocity and you should apply appropriate value of B0. Okay, so this formula basically tells you that what if you expect a particular amount of magnetic flux, then what should be your V0 and B0. Okay, next. So you can also think about a problem being asked on this particular formula that way if the magnitudes were given. Part B, I think we did not complete the first part. First part is complete. Now part B, the angular momentum. Okay, so angular momentum is r cross omega, but what happened here? Since these are only in one direction, okay, this is simply one directional vector. Therefore, there is no cross product involved in here. So simply you get mv0 r. Okay, and so we know V0 is already given. R you can substitute it from here and you will get the expression for L. Okay, and you can also find out the direction. So next one, since this is circulating a charge, like we are going now for angular momentum is done. Now we are going for magnetic dipole moment. So for magnetic dipole moment, we will need, what do we need for magnetic dipole moment? How do we define magnetic dipole moment for a charged particle in a
Current
circular
into
motion?
area.
The current into area. Okay, and how do we get current? Current will be basically charge upon time. This is a circular motion, so it is repeating basically. So you can take the period, okay, as a time and charge moving in that particular loop. So Q by T, and T is the period of that circle, a circular motion, which will be simply, you can express it in terms of angular frequency also, that is omega by 2 pi. Okay, and for omega will be right, omega we can get it from here, right, V0 by R, which will be Q B0 upon M. So V0 by R will be omega and that will be equal to Q B0 by M. So we can substitute in here. The dipole moment is, as we discussed, a dipole moment, simply the current passing through this, our basically formed because of the motion of this charged particle. If we take a conductor, let's say circular conductor, then the current flowing through that conductor and the area area of that loop. Okay. So out of these two quantities, we got I, we have A here. So if we just substitute in mu, we will get the magnetic dipole moment. Okay. Where omega is, as I said, omega will be q0 by m. V0 upon r will be your angular velocity, angular frequency also you can call it. So is this clear? Mu, the angular magnetic dipole moment.
Yes, sir.
So far, okay. Now next C part is very easy because you just have to take the ratio mu upon L. No, mu upon L. So L is there, mu is there. You simply take the ratio and you get the answer. All right, Q by 2m. Why do we ask mu by L? Because it gives you a constant. Okay, it gives you the constant, means it is not dependent on any system parameters. Mu upon L. That is the dipole moment, magnetic dipole moment upon the angular momentum, simply gives you q upon 2m. Okay, and q is constant, m is also constant. For the electron, can you calculate quickly mu upon L, the ratio of magnetic dipole moment and angular momentum of electron moving in a circular motion? Can we calculate quickly for electron?
So it will be on the order of 10 to the power 10.
Okay, q is 10 to the power minus 19 and divided by 10 to the power minus 31. So it will be of the order of minus 12. Yeah, then you will have 1.6 and divided by 9 point. So yes, 10 to the power minus 11 I can expect, and divided by 2. So you can say again 10 to the power minus 12. Okay. Is that clear? How did we get q upon 2m as for the electron as 10 to the power minus 12? So for any given particle for which if you know the charge on it and mass of it, you can calculate the mu upon L. You don't need any other information. That's the good thing about this particular ratio. And in physics, you will see so many such ratios like E by M and all, where they do not depend on system. Okay, because if you see here, it's simply constant. It is not dependent on what was the initial velocity, what is the magnetic field applied, as well as what is the radius of the circle made by the conductor. It simply comes out to be a constant, and which depends on simply on charge of the particle and mass of the particle. Okay. Now, in it's a electrostatic as well as a mechanics problem. So you are asked to find out the work done in moving a point charge Q having a charge of minus 5 microcoulomb in an electric field. The electric field equation is given from a point A to point B. Okay. So how do we proceed? Work done in moving a point charge Q from point A to point B. The electric field equation is given. So what is work done?
So we can find the force acting on the charge by multiplying the charge value by the electric field and then integrating it from one point to the other. That would be the work done, like integrating it with respect to the displacement.
Exactly. The work done basically is force times the displacement. If a force and displacement are vector, then you will have basically F dot D, which we saw in the dot product example. Okay. So here you are supposed to find out the force, because displacement you will know because we are given that it is moving from A to B, right? So if it is moving from A to B, the displacement part is clear. Now the force part. The force part, we know the force exerted by electric field. If it is simply at a point, then you can simply take Q times E. But since it is continuously acting and it is dependent on the electric field is dependent on if the electric field was constant. Okay, just just a constant value, let's say 10 volt per meter, then you could have simply multiplied Q times E and you get the force. Okay, but here it is dependent on theta and R. So therefore you have to, since when you go from A to B, R and theta both are changing, at least theta is changing, R is constant, 10 10. Okay, so you have to integrate this particular electric field, because the force acting at each point, at each value of theta, the force is acting and it is changing. Therefore you have to integrate the uh, the electric field by multiplying the charge in order to get the total force acting on this particular charge particle. Okay, so for that, okay, and another complexity here is that we have to use the polar coordinates. We are not we do not have simply the Cartesian coordinates. So that is another thing we have to consider. So let's start with, we are given that the radius of the uh, the value of R. Okay, because at A it is R is 10, at B also R is 10, so R is going to be a constant. That is that should be your observation first, that R is 10 and is constant. Only theta is changing. That is what we discussed, that it is going from pi by 6 to pi by 2. All right, so if theta R is constant and theta is changing, it is obviously a motion along a circular arc, or it is along a circle, right? In polar coordinates, then you can convert this basically R and theta in terms of L, and then we will, since we have to integrate the electric field with respect to this curve, that is the dl. Okay, so we have to take the line integral, okay, of the electric field, and then this will give you the total electric field acting on it, and then sorry, the electric field times your displacement dl, which we will get from theta, change in theta, will give you the work done, because Q times E is your force and this is the displacement dl, okay, while going from A to B. So this gives you the total force acting on the charged particle and times the displacement while moving from A to B. So that results in your work done. As I said, if E is constant, then simply Q times E into total displacement, that is A into B. That is your simplest formula we know for calculation of force, and then the displacement is also like simply A to B. All right, since it is varying, theta is varying, therefore you are supposed to integrate it. So theta component is varying only, therefore you will have E dot dl. So E dot dl, okay, so dl is your vector in theta direction, E is a vector in r as well as in theta direction. If you take the dot product, what will happen? Theta dot theta will be only be considered, and theta dot r will disappear. Why?
Since it's an orthogonal coordinate system, so
They are perpendicular to each other, right? We
yeah.
discussed in the beginning that the dot product of perpendicular vectors is 0, whereas the cross product of parallel vectors is 0. All right, so r dot theta will be 0, and therefore this particular part is not considered. Simply you have theta components which will preserve. So we will have 4r cos theta times r times d theta. Now we have the E dot dl in terms of theta only. Okay, there is r, but we know that r is constant while going from A to B, so you can take it outside easily. So you will have 4r square q outside, inside you will have simply cos theta d theta. Okay, and then you have the limit for theta at point A, theta was pi by 6, and at point B, the theta is pi by 2. Therefore, you can apply, you can set these limits and simply solve. Okay, r is constant, which is 10, so you can use that. You could have taken it outside, that is not an issue. It is not necessary to put it in this particular integral because it is only dependent on theta. So you get this now, that is cos theta d theta. What is the integral of cos theta, integration of cos theta?
Sin theta.
Minus 1.
Come on. That's very simple, right? Okay. So I just want to know that you are still there. Good. So we get sine theta, and then we substitute the limits for sine theta, limits of integration. So pi by 2 to pi by 6. So sine pi by 2 minus sine pi. So you get the half. Okay. You get the half for this integral. Then you have q times 400. So you will get essentially the work done, total work done, while moving the charged particle from point A to point B. Now we have in terms of Q, so you can substitute the value of Q. Q is minus 5 microcoulomb, so you can substitute Q minus 5 into 10 to the power minus 6, and you get the total work done in joules. Okay, is that clear? Any doubt at any point? So we can quickly go to the next problem.
Yes,
Yes,
sir.
please.
Okay, okay. Unless you respond, I feel alone. Okay, so just uh, keep on exchanging. All right. So the next problem is again also electric field related problem. So an electric field is defined in a certain region of space. Here in terms of Cartesian coordinates, in terms of x, y, z. If see here x, ax, so a is constant, c is constant, and b is also constant. So 6 times b. So just be careful here. It's not ax, not by, and not cz. Okay. So remember here cz is coming at in the y direction, and by is coming in z direction. Where ABC are constant numbers, we are supposed to determine the set of values of this A, B, and C for which the electric field can represent a valid electric field. Now, what do we mean by valid electric field? Any
It
idea?
must be derived from the gradient of some scalar field, right?
Gradient of some scalar field. All right. What else? Can we build on that? Gradient of some scalar field. Okay. So now can we build on gradient of some scalar field? We don't have field, right? We don't have scalar field here. Or I mean, you mean potential, right? Scalar potential. But here we
Yeah.
have only electric field. So can we, I mean, we can use that information which you mentioned, gradient of scalar field. So can we take the curl of this gradient of scalar? What is the curl of gradient? If a particular field can be expressed in terms of a gradient of something, then curl of that particular field will be,
Is it 0?
yes, it should be 0. Okay. The electric field, Maxwell's equations coming back, the curl of electric field should be equal to 0. Then only it is called a valid electric field. Okay. So then only it will be a valid electric field. Okay. So del cross E should be 0. Since we have E, if you were right, if we express E in terms of phi, that is negative gradient of phi, but then we should have information about phi, and then we can use that information. But we don't have phi, we have directly the expression for E, so we are directly using del cross E equal to 0. Okay. Now, how do we get the curl? Curl of electric field or any vector basically. Now here, if you remember in the definition of curl, basically it was E1, E2, E3. That is basically the components, the coefficients multiplied to I, J, and K. So you get it from here for I, X. Is it visible? I mean, it is readable, right? The
Yes,
fonts
sir.
is little small. Okay. So you get AX, then you have CZ for Y, and For Z direction, it is the coefficient is 6 times By. Okay. Now, can you solve this curl and tell me the answer? Can you solve this determinant?
Sir, is it 6B minus C I cap?
Yes, that's correct. So you get 6B minus C, that is X component. Okay. What about Y component? I mean, you already have the final answer, but what is Y component? I want to get it from another students. How do we solve this determinant? I think, do I have to explain how do we solve this determinant? No, right?
It's a 0.
Y component is
0.
0. Z component is 0. Why?
Also
You
0.
can you don't even have to solve this here, like for Y and Z, because if you take Y component, which is J times this into this and this into this. Okay, so you'll see double by double X differentiating 6by. There is no X there, so it is going to be a constant. So for constants, derivative with respect to X 0. Similarly here, there is no Z involved in AX, so therefore it is 0. Same thing is for Z component. So therefore they are 0. So you got 6b minus C. Okay, it is X component. So you can substitute here 6b minus C should be equal to 0. That gives you C is equal to 6b. Okay. So since C is equal to 6b, this is the condition we got for this particular expression of electric field to be a valid electric field. But we are asked what are the values of A, B, and C. We are getting just a relation. We did not get the value of A, B, C. Now we have to choose then. Okay. And since there is no restriction on A, we can choose any value of A. Okay. But for B and C, if we choose B, then C is fixed. Okay. So B and C, you can you can choose, and C then you will get as an from this relation. Okay. Fortunately, this was an objective problem, so we had options. Okay. So now, out of these options, which one will be valid? Which one will satisfy our criteria?
Option C.
Everyone agrees to that? Option C?
Yes.
All right, so we'll go with the option C. Why option C? Because option C only has this condition, that is 6 times B. B will be this, 6 times B is equal to C. And there is no restriction on A, so A can be anything. All right. So this way we can use our MCQ skills, which you might have developed during your 12th class, like JEE and NIT examination or CET examination. So that kind of like basically you are assuming that A can be anything, and you are just focusing on last two parameters. So we will have 13, 1 and 6. If you substitute in here and then again solve the take the curl of this electric field, you will get 0. Okay, that means it is a valid electric field. All right, next problem. Similar. So can I expect some hint from the students, like how do we proceed?
Yeah. If students have any problem they have to ask, they can ask. Any requirement.
So what is given? Just focus on what is given. A current distribution gives rise to a vector potential. As soon as vector potential, you read vector potential, what comes into your mind? Which relation? See, there are two potentials
B
in
is the curl of A.
electromagnetism, right? Vector potential and scalar potential. The scalar potential, whenever the scalar potential is mentioned, you should simply think about electric field. Vector potential is mentioned, you should think of magnetic field. Okay, so someone was mentioning something, please.
So curl of A is B.
Right. So del cross A gives you B. Okay. Now, so you have a vector. So you, what is asked? Calculate the magnetic induction B at point P and magnetic flux through the surface. So let's focus on A part first. So what you are supposed to do, B bar will be equal to del cross A. You should first solve this del cross A, get the del cross A, and then simply substitute x equal to -1, y equal to 2, and z equal to 5. Can we do that?
Yes, sir.
Okay, so maybe quickly solve it.
So just 2 minutes.
Yeah, others also please try to solve it. So this is the expression we are thinking about, and we know how to get the del cross A. Here, what is changed? You know, whenever you take the del of curl of a vector, first two rows remain same. Only the third row changes. That is based on what is your A vector. What are the coefficients of your A vector? Based on that, basically, this this determinant can be written. And as we discussed, determinant is solved like you can take the I cap dabba by dabba y of this particular quantity and dabba by dabba z of this quantity, and wherever there are no quantities involving with respect to which you are deriving, you are differentiating, then you simply write 0. You don't have to write the whole quantity. That makes it relatively simple and quick. So what is z component? Did we get z component, someone?
Y squared minus X squared.
Z component.
Of the final answer you are saying, right? Magnetic fields.
Oh, okay. No, I just asked Z component.
Oh.
Anyway, if you have the complete answer, so we will go by component wise. It basically avoids mistakes. If you solve it like if you write a complete equation in one go, then there are chances you make mistakes. So you focus on like X component, Y component, and Z component. Okay. So you get the X component, Y component, Z component. Did you get the same one?
Yes.
Everyone? Or is it only one student solving? All right, so now when we write B bar, you will have this quantity minus 4xz I cap plus 4yz j cap plus y square minus x square k cap. Okay, that will be this expression. And then ultimately you substitute the x equal to -1, y equal to 2, and z equal to 5. And then you get this. Okay, what is this T?
Tesla, unit of magnetic
Tesla.
field.
Okay. Now, how do we know that it is Tesla? I mean, how do we know that it is its unit should be Tesla and not like uh, sorry,
Potential field is in Weber per meter square.
exactly.
Weber
It
per
is in
meter.
SI. It is SI, in SI unit. So therefore, you can safely say that it is in Tesla. All right. Now, the magnetic flux through the given surface. The surface here is x going from 0 to 1, y going from -1 to 4, and z is equal to 1. So z is constant, that is 1. So now what is magnetic flux? You have the magnetic induction. How do we define magnetic flux? How do we define
Magnetic
flux
induction.
in general?
Magnetic induction per unit area.
Okay, per unit area. But here our magnetic induction is not constant, is a vector. I mean, sorry, it is not a scalar, it is a vector quantity. And it is not constant also, because if you change x, y, z, you will get some different values. So it depends on x, y, z. So it is not constant and it is vector. Then how do we get magnetic flux? whenever you want to find out something which is not, you want to find out the total of anything which of the things which are not constant and vector, then you go for integration, because you have to consider the magnetic induction at each point in that particular region. The region is given here, the x bound, y bound and z bounds are given. So within that region, how the B is varying, what will happen at each point. Okay, and collectively they will give you the outcome, that is magnetic flux in our case. Okay, so now can we get an expression, get an idea of the expression? So you are supposed to integrate, right?
Yes.
Okay, integrate what? B with respect to
Area element.
area element, that is ds, and since we have z equal to constant, so the area will be coming from x and y. Okay, and okay, just tell me, is area a vector?
Of itself, it is not, but we define a vector to be normal to the surface.
Exactly, because you know the cross product gives you the area, right? It gives you the area between two vectors, and with the direction perpendicular to the both the vectors. So you can treat area as a vector element, vector quantity, and therefore you have a dot product here. This ds is your surface area, okay, and you have dot product here. Okay. Now in Cartesian coordinates, it's very simple. ds is equal to in
dx
Cartesian
dy.
coordinates.
dx dy.
It's simply dx times dy, but it is a vector.
Dx dy n cap, where n cap is the unit vector normal to the surface.
And in which direction it will be? The normal n cap will be
Z direction.
z direction, because x and y it is varying, z is constant. So the ds direction is in z. Now you are taking dot product of b with respect to a vector which is only having z direction. What will it be? What
Only
will be
the Z
the b
component would
dot
survive.
ds? B dot ds will be simply having bz
Yeah.
times dx dy. Why not? We have here x component non-zero, y component non-zero, and z component also non-zero, but only the z component survives because ds is having a direction perpendicular to x and y, that is in z direction. So only z, that is k direction. So k dot k will be 1, whereas k dot j and k dot I will be 0 because they are perpendicular to each other. Okay, so you will simply have b dot s as bz times dx and dy. Okay, and then it is relatively easy. You can substitute bz in this integral and dx dy and take basically double integral. Just solve this double integral and you get the magnetic flux. Okay, in terms of phi x square 35, 65 by 3 minus 5x square, because there are two subsequent integrals, double integral. And when you substitute the limits, since ultimately you got everything in converted in x, so then only x limits are applied 0 to 1 and you get phi equal to 20 Weber. All right, this is Weber again because your initial unit was mentioned. Otherwise, you simply write in units. All right, I think, sir, shall we continue or?
Let students decide whether they want further more problems or not.
Okay, so students, please, shall we continue? We can take a couple of more problems.
Yes, sir.
All right, everyone, I'm just hearing one voice. Anyway, that is even then it is
Sir,
worth. Yes, sir.
if you can take any problem from the part B, just for an example.
part B, you mean this refute and support
Refute and
kind of
defend or refute, or
defend or refute?
comment,
Okay.
like comment.
Okay, okay. I think I
Definitive.
had a problem on that, but I think I converted them into normal problem. But let me see. I think I have one problem like that. This one, no. Okay. So I think the next, yeah, this one. No, this is from part, I guess, the C part. Okay. Just let me make sure that I have. No, I think I convert those questions in normal questions actually.
Okay. Even if you have some such of the problems, you can post it on this group, so students will
Sure,
easily
sure.
get
I
it.
will share this particular
PPT.
slides. Yes,
Okay.
with the
That's very
students in
fine.
the
That's
group.
very fine.
I can send.
Just
Okay.
give some basic
Okay.
idea how
So
to
about
make
that
statement.
particular part B, that is refute and like
Defend.
you are supposed to defend whatever the answer you are writing. So there will be two choices you are given, like let's say something is true or false. And if it is, let's say what you assume you are sure that this is true or false, whatever it is, then you are supposed to also defend. That means you are supposed to give the arguments in support of your choice. Okay. For example, let's say this question particularly. Okay, the electric field expression is given, and let's say you are asked whether this electric field is valid electric field. Uh, refute or means
Defend.
true or false. Okay. Now you have a choice. You made a choice. Now you have to support your choice. How do we support? We already did, right? Valid electric field. We will take a del cross E and show that it is 0. If it is 0, then your choice was correct. If you have chosen yes. Otherwise, so basically you are supposed to solve that problem, or you are supposed to analyze that question, get an answer, and based on that you will write your answer, whether you are you are supporting that argument or you are not supporting that argument. Okay. So it is in a way like a conceptual questions will be asked in that particular section, and you will have to make a choice. But not only choice, you also have to support it, give the supporting statements in favor of that or against that, whatever is your choice. I think one more question can be, yeah, what are conservative, non-conservative forces? So a conservative, let's say you are given again a particular force equation, and you are asked whether it is conservative or not non-conservative. Okay, and or you can yeah, or the statement is made that this particular force is conservative. Okay, let's say frictional force is conservative. So do you support this statement?
No,
Frictional forces are conservative. No, right? So you have mentioned that it is, answer is no. Now you have to support. How do you support it?
because work done by a non-conservative force is path dependent. So if I take a closed loop and if I like perform work on a particle, the
Exactly.
answer will
So
not be zero.
basically, you should know that concept. Okay, you should know what is conservative and non-conservative. Once you know that definition, then it is easy to show. Okay, or it is easy to support. All right. So then I think we will take questions if there are.
Sir, I want to just make one comment.
Yes,
Uh,
please.
Usually, we don't ask these type of questions in our examinations, university examinations. Very
Right,
rarely I
right,
find these
right,
type of
right,
questions.
right, right.
So students are not that they are not comfortable with such questions. So how to
Such
defend or how to
questions.
defend a
Right,
statement?
right.
It requires a lot of thinking. It is application part.
Exactly.
deriving a derivation or writing some statement and
Writing,
explaining
yeah,
something, that is
MCQ
difficult.
and derivation is very relatively used, means not easy, but you are used to it.
Yes, that I find
But
this is very challenging part for the physics students. So
exactly,
their analytical skills is that that requires
are used,
analytical
right,
skills.
right, right.
Yeah, revise
Kind
the
of
problem.
different kind of thinking is
Yeah.
required. This was very straightforward actually. Whatever I asked, conservative, non-conservative, but there will be very interesting statements made, and you are supposed to analyze those statements and what they mean, and then you are supposed to take a stand and write the answer in support of that stand.
Yes. There is one very typical question I had asked in this because in the today I have posted one paper, practice paper.
Uh-huh,
In
uh-huh.
that case, there is one very simple statement. Pauli's exclusion principle stabilizes the material, so it is responsible for the existence of attention, like that. So explain.
Right, right,
That's a
right,
very easy question. But I
right.
found that no one could. In my class, I asked same similar question today in the class, but student couldn't get an idea how it is responsible. Like Paulison principle is basically responsible for stability of atom, and that's why
Exactly.
further things are possible. So this type of understanding part is very little,
Right,
and
right.
that causes a problem to our students. Yeah. Okay. I think we are about to finish. 1.5 hours is our schedule. So whatever you have,
Yes,
you
yes.
can
I mean,
share
I
all
had
these things
more
on the
questions.
group.
I mean, I
Yeah.
prepared some more questions also. But anyway, I can share this PPT, and students can always ask
Yeah.
questions or doubts if they have. I think you can share my email ID with the students,
Yeah.
even phone
Sure.
number. I don't mind.
So please, Manisha ma'am, can you conclude?
Yes, yes, yes. Thank you so much, sir, for the valuable guidance and making this lecture very simple. Also, you have engaged all the participants, that is, including professors, including students. Everybody was the part of it, and everybody enjoyed listening to the lecture and doing actually solving the problems with you. So it was quite enriching lecture, sir, motivating lecture, and inspiring our students for this NGPE exam. So on behalf of IAPT Pune region, as the president, I am very much thankful to you. We are indeed very grateful to you, sir. Also, I am thankful to Rekha Ghorpade madam to provide this particular platform. We are thankful to Kangude sir for arranging such lecture series on IAPT Pune behalf, and every office bearer of IAPT Pune region, all the EC members and all the students, professors who were part of this lecture series and part of today's lecture. I am grateful to them, and we are indeed truly fortunate to have you as the speaker, sir. You really enriched our students' knowledge, and we are indeed very much thankful to you. I am thanking you on behalf of all and everyone in this meeting. Thank you all.
Thank
Before
you. Thank you.
conclude, let me
Yeah.
mention that the students' lecture has been recorded on the YouTube itself. It will be
Yes.
made available on the portal of IAPT, as well as its link will be shared to all our students. One more thing, tomorrow there won't be any session because of the election part of elections in the state. On 17th, we will have next session by Dr. P.S. Kamble, sir. So this is for the information for the students. Okay,
Yes.
thank you.
Yes,
Yeah,
sir.
over to you, ma'am.
Good night. Good night, everybody. Yeah. Bye. Thank you
Yeah,
all.
thank you all. Thank you all
Bye.
being
Good night.
being
Thank
part
you.
of this
Thank
session.
you.
Yes. Okay.